You would have heard that the universe is expanding, but do you know why it is expanding? In our voice today, we'll be exploring the reason for the universe expansion. We believe that the universe is expanding because of this mysterious force that you call dark energy. There's very little we know about dark energy, but we know that it makes most of the universe. Similar to dark matter, its name doesn't mean actually that it's dark, it just conveys the absence of knowledge about that topic. Dark energy is known to be the opposite force of gravity, meaning it causes the universe to expand and is the reason for its accelerating expansion. Now, this might make you wonder, will the universe ever die? Is there a way it will end? And scientists do have pondered over this question, come up with various ways the universe could end. But to know how the universe will end, we need to be able to calculate it in some way. And this is done through the average density of the universe. The average density is the mass of all matter in the universe, equivalent to the mass of energy. You might have heard of the equation equals to mc squared, which basically equivalents energy to mass, meaning an energy, a certain amount of energy, can be equivalent to a specific amount of mass. This is why we have atomic bombs. But still, including that mass, whereas all the matter that can be seen that is contained in each unit of volume, 1 cubic centimeter, is known as the average density of the universe. If all the atoms that make up stars, galaxies, planets, and other such astronomical objects, along with light and other energy, were distributed throughout space with absolute uniformity. The universe has a higher average density. It means that it has more mass and more gravity. This allows it to slowly contract and reverse the expansion that's occurring. On the other hand, if average density of the universe is lower, then it means that there's no way to stop the expansion of the universe and it will expand forever. But we need to be able to compare the average density of the universe against a certain benchmark to be able to tell whether it's higher or lower. And this is why we have the critical density, which is the density of the universe that it must have to be able to slow down the expansion to zero, which means it's neither expanding nor contracting, it's at a stable state. This can be done on the basis of the current rate of expansion of the universe. So if the average density of the universe is higher than this critical density, it means that the universe will slowly reverse its expansion and contract back. Otherwise, it will expand forever. Using these two main factors, there are four main ways the universe could end. The graph next to me, which may just seem completely confusing, but focus on the first one, labeled as 1. The first curve demonstrates the universe, the big crunch will occur. It means that the universe will expand. There will be a point when it will reverse and slowly come back and reverse the entire expansion process. So just look at the Big Bang and reverse the time. You'll see it crunching. That's why it's called the Big Crunch. In this scenario, the calculated density of the universe is greater than the critical density, which we discussed before. This means there's more gravity, allowing the universe to halt its expansion. This could eventually lead to the contraction of the universe, resulting in a big crunch. This model of the universe is known as the closed universe, as the scale of the universe decreases to zero. So the shape is closed. It's no open because it goes back to how it usually was, which means space would have contracted to an infinitely small volume of size, like how it was in the Big Bang. It just reversed. In such matter, energy and space would all be crushed out of existence. Yes, it sounds harsh. Some theories say that another Big Bang might follow the Big Crunch, followed by another Big Bang. Our universe would be stuck in an oscillating pattern of a Big Bang followed by a Big Crunch. Some theories are referred to as the oscillating theory of the universe. At the moment, as we have observed that the rate at which the universe expands seems to be accelerating due to dark energy. It seems unlikely that a universe may die in a big crunch. But our theories of dark energy may be wrong. Maybe we are miscalculating something or ignoring some other aspect and require more knowledge of this unknown energy to arrive at a proper conclusion. Big freeze. In this case, the calculated density of the universe is less than the critical density, meaning gravity is not able to hold the expansion of the universe, causing it to expand forever. As you can see next to me, is shown in the second curve of the graph, where it expands, but it does slowly slow down, but not enough to completely go back to a contraction state. And it's known as the open universe. And space are properties that were created in the Big Bang and have no end in such a universe. They continue to exist forever. This is known as the Big Freeze. In the Big Freeze, as I've previously noted in the graph, the universe expands, but at a slower rate as time increases. The groups of galaxies are so apart from each other that it is close to impossible for observers to spot them, meaning a future you will be unable to even know whether there's other galaxies out there, or other exoplanets, or other life out there. You'll be isolated from the rest of the universe. The scenario is a flat universe, and I'm sure you can guess by the name what it means. If the actual density of the universe was exactly equal to the critical density, then the universe would expand forever, but at the slowest rate possible. As you can see next to me, this is displayed in the third curve of the graph, where it expands, but it slows down at a time. It's at the slowest rate the universe could expand. And this will result in a flat universe. If there was even one extra particle, then the universe would contract. Or if there was one less particle, it would expand forever. The last one is the big rip. The universe contains dark energy, and we are right about it. Then the rate of expansion will increase over time, like how it is right now. This is shown in the fourth curve of the graph, where the universe expands at an ever increasing rate, bringing the matter is closer together, like how it was during the Big Bang. At this time, the influence of gravity is greater and dark energy acts only at large scales. But as the rate of expansion increases, matter spreads out and dark energy starts dominating, even at smaller scales. This will lead to a big rip. This would eventually cause dark energy to rip out single atoms, leading the fabric of space and time to be torn apart by the expansion of the universe. Well, none of these sound very pleasing end to the universe. Hopefully, we'll be able to come to a proper conclusion of how the universe will end. It can only be done if we gain more knowledge about dark energy and how the universe is expanding. But on our next voyage, we've been encountering another explorer on a voyage to the cosmos, a female astrophysicist to be precise. Don't forget to watch the Role Model series, where we've been learning from the experiences of an astrophysicist on a voyage to space. Till then, see you.